Can we survive on Mars? Artemis 2 holds the answer. For centuries, we've stared up at the red planet and wondered, could we actually live there? It's a dream that has fueled countless sci-fi stories and inspired generations. But turning that dream into reality is another story entirely. It means a journey of up to 9 months through a sea of invisible, damaging radiation. No chance of a quick rescue. Every single breath and every sip of water would depend on technology that absolutely cannot fail. So, where do we even start to tackle a challenge that immense? Surprisingly, the answer isn't found by blasting off directly for Mars. It's being figured out right now, much closer to home. The answer begins with a trip back to the Moon. The Mars problem, a brutal reality check. Going to Mars isn't like anything humanity has ever attempted. The scale of the challenge is just staggering. NASA has a list of 5 big hazards for human spaceflight: radiation, isolation, distance, strange gravity fields, and living in hostile, cramped environments. A mission to Mars checks every single one of those boxes in the most extreme way imaginable. First off, there's the trip itself. Astronauts will be stuck in a tiny spacecraft for 6 to 9 months, just one way. And once they get there, they can't just pack up and leave. Because of how the planets align, a round trip could stretch to 3 years. The whole time, they'd be bombarded by galactic cosmic rays and solar particles. Mars doesn't have a global magnetic field to protect it, so radiation just rains down on the surface. An astronaut on a Mars mission could be exposed to incredible levels of radiation, which poses long-term risks for cancer and other diseases. That's a threat you can't easily solve with just shielding, not without adding tons of weight and cost to the mission. Then there's what happens to the human body. Long stretches in microgravity wreak havoc on us. Astronauts can lose bone density at a rate of 1 to 1.5% every month they're in space. Muscles, including the heart, start to waste away because they aren't working against gravity. Fluids shift up into the head, messing with vision and balance. We've studied this on the International Space Station, but a Mars mission is a whole different league, way longer and far more intense. Finally, you have the psychological toll. The isolation is total. A crew on Mars would be, on average, 140 million miles from home. A radio signal would take up to 20 minutes to travel one way. Want to have a conversation with mission control? Forget it. A simple question means a 40-minute wait for the reply. They have to be completely self-reliant, ready to handle any emergency, from a medical crisis to a busted system, all on their own. Why not go straight to Mars? Lessons from our backyard. So, if Mars is the ultimate goal, why are we spending billions to go back to the Moon? It's a fair question. Why not just rip off the band-aid and aim for the red planet? The answer is orbiting just a few hundred miles above our heads, the International Space Station. For over 2 decades, the ISS has been an amazing laboratory, teaching us how to live and work in space. We've learned about microgravity, tested new gadgets, and figured out the basics of recycling air and water. But the ISS has a huge safety net. It's still tucked inside Earth's protective magnetic field, which shields it from the worst of deep space radiation. Resupply runs are common, and in a true emergency, a crew can be back on the ground in a few hours. Going to Mars without first testing our gear in a real deep space environment would be like trying to cross an ocean without ever sailing out of the harbor. The ISS taught us how to walk in space. Artemis is about learning to run. The Moon is the perfect middle step, far enough to hit us with the real challenges of deep space, but close enough that a trip home takes days, not months. The solution, Artemis as the proving ground. This is where the Artemis program comes in. It isn't just Apollo 2.0, it has a totally different goal. While Apollo was a sprint to prove we could get to the Moon, Artemis is about learning how to stay. It's a step-by-step plan to build a long-term presence on and around the Moon, all with the clear goal of getting humans ready for Mars. The program is designed to solve the biggest problems of a Mars mission, one piece at a time. It will test new technologies, let us practice long-duration stays, and even let us try using local resources, like water ice at the lunar South Pole, to make breathable air and rocket fuel. And the very first crewed mission of this new era, the one that will really start to answer the question of Mars survival, is Artemis 2. The star of the show, Artemis 2, the first real test scheduled to launch no earlier than March 2026, Artemis 2 will be the first time in over 50 years that humans fly beyond low Earth orbit. A 4-person crew will take the Orion spacecraft on a roughly 10-day journey. They'll fly on a free return trajectory, which uses the Moon's gravity to swing them around the far side and slingshot them back toward Earth. They won't land, but what they will do is arguably even more important for the future of deep space exploration: a full-scale shakedown of the very systems needed to keep people alive on the way to Mars. The heart of this test is Orion's Environmental Control and Life Support System, ORACLES. This is the hardware that gives the crew clean air, drinkable water, and a stable temperature. Research from the ISS laid the groundwork for these systems, but Artemis II is their first trial in the harsh reality of deep space. A key focus is the carbon dioxide removal system. Here on Earth, plants and oceans do that job for free. In a sealed capsule, CO2 buildup is lethal. The crew will push the system to its limits, exercising to produce more carbon dioxide and making sure the hardware can handle it. This is direct rehearsal for the closed-loop systems needed for a long Mars trip, where recycling every last molecule of oxygen is critical. They'll also put the water dispensers and the new, advanced space toilet through their paces. It doesn't sound glamorous, but proving you can reliably manage water and waste is absolutely vital for a 3-year mission where you can't get a resupply. The mission will also test Orion's heat exchanger and fire suppression systems, the tools that could save the crew during an emergency far from home. Every procedure and every piece of data is meant to confirm the best ways to live and work in deep space. More than machines, the human factor, but surviving in deep space is about more than just reliable machines. We have to understand what it does to the human body and mind. Artemis II is a vital science mission focused on astronaut health. For the first time since the Apollo missions, we'll collect detailed biomedical data on humans outside the protection of Earth's magnetic field. As part of a study called Archer, the crew will wear monitors to track their sleep patterns and activity levels, giving scientists a rare look at how the body's rhythms adapt to deep space. They'll provide saliva samples throughout the mission to analyze biomarkers, helping researchers understand how the immune system responds to the combined stress of radiation and isolation. And speaking of radiation, Orion is packed with sensors to measure the deep space environment, while the crew tests out radiation protection gear inside the capsule. Another fascinating experiment, called Avatar, will fly organ-on-a-chip devices. These tiny chips, seeded with the crew's own human cells, will let scientists see how deep space affects tissues and organs in real time, helping to create personalized medical treatments for future explorers. This flood of data, from sleep quality and stress hormones to immune response and radiation effects, is priceless. It will form the bedrock of knowledge we need to select, train, and protect the first astronauts who make that long journey to Mars. Building the future, beyond Artemis II is just the first step. The data from its 10-day flight will directly shape the missions that follow. Artemis III aims to land astronauts on the lunar surface, specifically at the South Pole, where we believe there are deposits of water ice. Future missions will help build the Gateway, a small space station in lunar orbit that will serve as a jumping-off point for missions to the Moon, and eventually, to Mars. These missions are essentially dress rehearsals for Mars. Astronauts will practice long-duration stays, test out new rovers and habitats, and learn to live off the land by extracting resources from the Moon. Each step builds on the last, systematically knocking down the risks of sending people to Mars. NASA's strategy is clear. First, learn to live on another world that's close by, before taking that next giant leap. The journey to Mars is one of the most ambitious things humanity has ever tried, and it's happening right now. The results from Artemis II will shape space exploration for decades. What part of this mission gets you the most excited? Is it the life support tech, the groundbreaking health research, or just the idea of seeing humans fly around the Moon again? Let me know your thoughts in the comments below. And if you want to follow every step of our journey from the Moon to Mars, make sure you subscribe. So, can we survive on Mars? The answer isn't a simple yes, not yet. But for the first time, we're actually building the tools to find out. Artemis II holds the key. It's not the final answer, but it's the mission where we finally start asking the right questions in the right place. It's the mission that takes the dream of living on Mars and turns it into a real, solvable engineering and science problem. For over 50 years, deep space has been the domain of robots. With Artemis II, humans are finally going back. Not just to visit, but to learn, to prepare, and to prove that our future isn't just on Earth, but out there, among the planets.